Welcome to Dimensional Analysis, the metric system. Our objective for this video is to learn how to maneuver through a metric conversion chart so that we can easily convert between metric units. In order to do this, you first need to know what dimensional analysis is, know what a conversion factor is, and know the rule for selecting a conversion factor. So if you don't know these last three things, you may be a little lost in this video. And if that's the case, go watch my other video, Dimensional Analysis, the nuts and bolts of creating ratios between units. I know it sounds riveting, but it goes into more depth with a lot of examples and it'll help you out. Otherwise, let's get started. All right, so first off, all metric conversion charts will supply you with basically the same information. There'll be a column with a written prefix, a column with an abbreviation of that prefix, and a column for multipliers for that prefix. And the multipliers will be given as an exponent as well as a number. Now the prefix is what's added to some sort of a base unit, such as grams or meters or liters. And that prefix will give us a clue about how much of something we're talking about. For example, you may be measuring distance, which would be in the base units of meters. And let's say you're just measuring a part of your yard to put in a garden. Well, typically this isn't going to be a great big area, so you may only be measuring 2 meters by 3 meters. Now, on the other hand, let's say you're planning a trip to Texas. Well, now the distance would be significantly larger than what we would be measuring out for our garden. And we would typically report that trip in terms of kilometers or kilometers. Now, a mile is equal to about 1.5 kilometers. And from where we live in New England, it's about 2,600 miles to Texas, which would be about 4,200 kilometers. Now, if we were to give that same measurement in meters, we would have to say 4,200,000 meters. But by assigning the prefix of kilo to our base unit, meters, we can now express these larger units of measure more easily. And that's great and all, but how do we know how to move through these prefixes and multipliers to create conversion factors for our problems, specifically our homework problems or exam problems? Well, let's start first of all by selecting a couple of pieces of information from this chart right here. Let's take kilo and milli, and we're going to move them to a scaled down version of this chart to make it a little bit easier to deal with. So here we have a simple scaled down version of our metric chart with our prefix, our symbol, and our two multipliers for our kilo and our milli. Now I've put in a blank row between the kilo and the milli, and in this row I'm going to add what's called a base unit. The base unit is basically your starting point. It's the unit that the prefixes get added to express different amounts. And the base unit that we're going to use is the gram. Now gram has a symbol of G and its multiplier is 1. In fact, all base units have the multiplier 1. Now our kilo, if you take a peek, is now kilogram, and our milli is now milligram. So we've added the base unit to our prefixes, and I've just basically filled in this chart a little bit more by adding the base unit to everything. So as I explained on the previous chart, where grams expresses mass, let's say in units of tens or hundreds, kilograms will express mass in units of thousands, so that 2 kilograms would be 2,000 grams. Or on the other hand, milligrams could be used to express much smaller masses that would be 1/1000th of a gram. So basically the point I'm trying to make is that if you go above gram to kilogram, you're now talking in much larger quantities, and if you go below gram to milligram, you're now talking about much smaller quantities. So let's take a look at an example of how we would use this chart to make those types of conversion. Let's convert between grams and kilograms. Now, what's the relationship between these two? Well, you may know off the top of your head that 1,000 grams equals a kilogram, but how did you come up with that? And that's the big question here, right? So in our problem, we are given 1 kilogram and we want to answer how many grams that is. So we're asking to convert 1 kilogram into grams. And clearly we need a conversion factor, right? Of course, that's what this entire video is about. The units that we're given are kilograms, so we're given kilograms, and we want our answer to be in grams. So what's the relationship between these two units? Well, if we look at our chart, we see that we have grams and kilograms right here. And I'm going to be using these symbols in my problem, so I've highlighted them just so you can see what they are. And if we move to the multipliers, we have these two multipliers. We have 1,000 for kilogram and 1 for gram. And in this example, I'm going to be using these numbers as opposed to the exponents, just for simplicity. In another example, I'll actually use exponents, but for now, we're just going to stick with the numbers. So let's set up our equation, and then I'll explain how we're going to use the information that we've identified in this chart to create our conversion factor. So when we solve a problem, our first step is to take our given, which is 1 kilogram, and we're going to make it into a fraction by putting it over 1. Now let's place our symbols for our conversion factor first, and there's a reason why we're going to do that. Now you might remember the rule for creating a conversion factor says that what you seek goes on top. We're given kilograms and we want grams, so our units are going to be grams in our numerator, and kilograms are going to be what's in the denominator. All right. So that looks good so far. But the question is, what values are we going to put in there, right? Well, the values are going to come from the multiplier section of our chart, and I'm going to show you how we're going to utilize that. So we're first of all going to go to the multiplier for kilogram, which is 1,000, and we're going to plug it into our grams, so that in our numerator we are going to have 1,000 grams. And then next we're going to go to the multiplier for gram, which is 1, and we're going to plug that into kilogram, so that if we put that in our denominator, we're going to have 1 kilogram in our denominator. And basically with this little sleight of hand, you've created a conversion factor that's going to help us solve our problem. So let's finish working our problem. So we've set up our given as a fraction, and we've created our conversion factor, and now we're moving on to step 3, which is that we cross out anything that's repeated in the numerator and the denominator, and in this case that would be kilos, so our kilograms are going to go away. And now we're at step 4, which means we do our math. And multiplying the numerators, we have 1 times 1,000 grams, and in our denominator we have 1 times 1, so our answer is 1,000 grams over 1, and our final answer is simply 1,000 grams. And we can ask ourselves, is this true? Does 1,000 grams equal 1 kilogram? Yeah, it does. Most of us know that. And in fact, we've just proven that that is true using our chart. So the system seems to work, and that's a good thing. All right, let's work another problem. And this time we're going to use grams and milligrams. We're going to convert between these two. So bring up a problem here. Our problem says convert 1 gram to milligrams. So looking at just our units, we are given gram, and we want our answer to be in milligrams. So the units we seek are going to be milligrams. Now let's go to the chart and identify our players. Here we have grams and milligrams. Those are our symbols. And then we're going to use these multipliers. We're going to use the multiplier 1 per gram and the multiplier 0.001 for milligram. Now the first step in solving our problem is to take what we're given and make it a fraction, which means we're going to put it over 1. So we're given 1 gram and we put it over 1. And then the second thing we're going to do when solving our problem is create that conversion factor. So when we're working with this metric chart, we are going to start by referring to what it is that we seek. And in this case, we're seeking milligrams, which means we're going to put our units on top, milligrams on top, and our grams are going to be on the bottom. So milligrams are what we seek, and they're going to be in the numerator. Grams are going to be put in the denominator. All right, so now let's go to our chart and see how we're going to use these multipliers to plug it into our conversion factor. So to get the values for our conversion factor, we're going to look at these multipliers. For milligrams in our conversion factor, we look to the multiplier for gram, which is 1. So we're going to take the multiplier for gram and apply it to milligram, which is 1. So let's plug that in. And then for grams in the conversion factor, we're going to look to the multiplier for milligram, which is 0.001, and we're going to plug that into our grams. And here we are, we've created our conversion factor from our metric conversion chart. So that's step 2. Now that we have our conversion factor, our third step in solving our problem is to cross out units that appear in both the numerator and the denominator, and that would be grams. We have grams here in the numerator, grams here in the denominator, they get to go away, and we have nothing else that will cancel. So now we can move on to step 4, which is to simply do the math. And multiplying the numerator, we have 1 times 1 milligram. Multiplying in the denominator, we have 1 times 0.001, and that gives us 1 milligram over 0.001. And we can further reduce this by dividing the top by the bottom, that is, dividing the numerator by the denominator, and our final answer is 1,000 milligrams. And does 1 gram equal 1,000 milligrams? Yes, it does. All right, let's work another problem. One where the units aren't right next door to each other in our chart. So let's make this conversion between kilograms and milligrams. So let's bring up our problem. And looking at what the units are, we're given kilograms and we're being asked to convert into milligrams. So we've identified our path and what we're going to as far as creating a conversion factor. All right, let's go to our chart and identify our players. So here we have our symbols, kilogram and milligram, and then let's identify the multipliers. And let's use 1,000 and 0.001. All right. Now that we have everything identified, step 1 in solving our problem says that we take our given and we make it a fraction by putting it over 1. So we take 1 kilogram and put it over 1 because we're given 1 kilogram. Second, we begin creating our conversion factor, keeping in mind that the units we seek are milligrams, which means that our conversion factor will have milligrams over kilograms. There we are. Now we go to the conversion chart to get our values to plug into our conversion factor. Now the value for milligrams is going to come from the multiplier for kilograms, which is 1,000. So we're going to plug that into milligrams. And the value for kilograms is going to come from the multiplier for milligrams, which is 0.001. And we're going to plug that in. And with that, we have created our conversion factor. So when we apply the multiplier to the opposite units, we're basically creating a relationship between these units. There is, in fact, a much longer way to do this, but this saves you a lot of steps. It's much faster and you're less likely to make a mistake and avoid potential headaches. So once you identify everything in your chart, plugging in the multipliers in this crisscross fashion is the way to go. Okay, now that we've created the conversion factor, now we can move on to the third step in our problem solving, and that is to cross out the units that appear in both the numerator and the denominator. And for this problem, that would be kilogram and kilogram. Nothing else cancels out. So we move on to our fourth step, which is simply doing the math. And looking at the numerator, we have 1 times 1,000 milligrams, and in the denominator we have 1 times 0.001, which gives us 1,000 milligrams over 0.001. And we can further reduce this by dividing the numerator by the denominator, and our final answer is 1 million milligrams. There are 1 million milligrams in 1 kilogram. Now, in all the previous examples, I've used the multiplier expressed as a number. Let's rework the previous example, the same problem, this time using multipliers expressed as exponents. So we're going to get rid of the numbers, and these are going to be our new players, these exponents. So the first thing we do is set up our problem, taking our given and writing it as a fraction. And now we set up our conversion factor, keeping in mind that the units we seek are milligrams. So milligrams would go in the numerator and our kilograms would go in the denominator. And just like we did for the other conversion factors, we're going to go to the chart to find our values. So for milligrams, we're going to go to the multiplier for kilogram, which is 10 to the third, and we're going to plug this in to our milligrams in the numerator. And next, for our kilograms, we're going to go to the multiplier for milligram, which is 10 to the negative third, and plug this into our conversion factor in the denominator. And voila, we have a conversion factor complements of our little chart. Now our next step in problem solving is to cross out those repeating terms, which we know is going to be this kilogram, top and bottom, and that nothing else is going to cancel at this point. So now we're ready to do our final step in problem solving, which is to do the math. Now when working with exponents, as long as the base units are the same, the only numbers that undergo any sort of manipulation are going to be the powers. And in our problem, both of the exponents have the base unit of 10. Our powers are 3 and negative 3. We have 3 in the numerator and negative 3 in the denominator. So how are we going to handle those? Well, you might remember from your algebraic career that when dividing exponents with the same base, you simply subtract the power of the denominator from the power of the numerator. It's going to look like that. How easy is that? And from basic math rules, subtracting a negative is the same thing as adding a positive, so we can rewrite this to look like that. So what may have looked to you like what was going to be a more complicated method of solving this problem is actually pretty simple and doesn't even require that you use a calculator. All right, so 10 to the power of 3 plus 3 milligrams can be further tidied up by adding those 3's together, which gives us 10 to the 6 milligrams. And this is equal to 1 million milligrams, which is the same answer as we worked in the previous problem using the numbers, the multipliers as numbers. So we're going to bring back our metric conversion chart and work a problem. So here's our problem. And here we're being asked how many liters is in 2200 milliliters. Now looking at just the units, we are given 2 milliliters and we're seeking an answer in liters. Now let's go to our chart and identify our players. Well, when we look at this chart, we only have one player, and that is the milli. Liters is not listed because it's a base unit. It's the starting point, remember? And with a base unit, the multiplier is always going to have to be 1. All right, now that we have all of that out of the way, let's begin setting up our equation. So first we start with our given, which we're going to express as a fraction, so we're going to have it over 1. And then second, we have to craft our conversion factor, keeping in mind the rule that states that the units we seek go on top. So let's start by writing the conversion factor with just the units. And the units we seek are liters, so we're going to write a conversion factor that is liters on the top line, which puts it in the numerator, and the units we're given, which are the units that we will eventually eliminate, will go in the denominator, and that's our milliliter. And now we have to go plug in values for our conversion factor, and we're going to find those values. At least one of those values is going to be in our chart. So to find the value to plug into our numerator, we're going to go to the multiplier for milliliter, which is 0.001. Find it there on your chart, and we're going to plug that into liters. And we have to simply know that we're dealing with the base unit liters and that its multiplier is going to be 1. And so we'll plug that into milliliters right next to our milliliter units. And with that, we have created our conversion factor. Now, the third step in problem solving is to cross out our repeating terms, which are going to be this milliliter on top and this milliliter on bottom, and nothing else is going to cancel. So now we're ready for our final step in problem solving, which is to do the math. Now multiplying the numerators, we had 2200 times 0.001 liters, and in the denominator we have 1 times 1, so our answer is going to be 2.200 liters over 1. And we can further reduce this to simply 2.200 liters. Keeping all of those zeros in place because we were given a value that was significant to 4 digits, and I'm keeping my answer significant to 4 digits as well. And if you don't know that, or if that's not ringing any bells, yes, I do have a video that you can watch on significant, actually I think I have 2 videos you can watch on significant figures. So go watch those when you have free time. All right, let's work another problem with this chart. So let's bring up an example right there. Here we're given gigahertz and petahertz, and we're being asked how many gigahertz are in 1.3 petahertz. So what are we going to look at first? We're going to look at the units, and the units that we're given are going to be these petahertz, and the units that we're being asked to give our answer in are going to be gigahertz. So now let's go to our chart, and we're going to identify our players. And we're going to find these guys at the top. So here is our giga, and there is our peta. And we see what their multipliers look like. Ooh, we have a lot of zeros in the numbers, so I'm going to use the exponents instead of the numbers to work this problem. I think that'll be easier. So the first step, now that we have everybody identified, our first step in problem solving is to do what? I hope you said is to take your given and put it as a fraction, because that's our first step. So what we have here is 1.3 petahertz over 1, and that is our first step. Our second step in solving this problem is to create our conversion factor, keeping in mind that the units we seek are going to go on top, and those units are going to be gigahertz. So as we write our units, not going to plug in values yet, we're just going to write units. It's going to be gigahertz over petahertz. Now we're going to go to the chart, and we're going to find our values that we're going to plug in. So for gigahertz, we're going to go to the multiplier for petahertz, and we're going to apply it to our gigahertz. Hey, look, because I have 2 values, I can use my blue and green arrows. Woohoo! All right, so let's see. We're using petahertz multiplier, which is 10 to the 15th, and we're going to drop that into our gigahertz. So we plug that in. And next for petahertz, we're going to go to the multiplier for gigahertz, and which is 10 to the 9th, and we're going to plug that into our conversion factor, which is going to be in the denominator. And with that, we have yet again created a conversion factor, complements of our chart. Now that takes us to the third step in problem solving, which is to cross out repeating terms, which in this case would be our petahertz. So we have petahertz in the numerator, petahertz in the denominator. They get to go away, leaving us with just the units we seek, which are going to be those gigahertz. And now we are at the fourth and final step in our problem solving, which is to do the math with what's left. So instead of multiplying straight across, we still have a little bit of work to do in our second term. We have 10 to the 15th gigahertz over 10 to the 9th. So instead of solving it like I have with everything else, I'm going to address each of these terms separately. So in our first term, we've simply eliminated the unit petahertz. So we can reduce that term to 1.3. Now we can deal with the second term, which is 10 to the 15th gigahertz over 10 to the 9th. And we do this by rewriting it like this. 10 to the 15 minus 9 gigahertz. Because remember, when we're dividing powers, or when we're dividing exponents, we're just going to subtract the powers. And that's really simple. So with this, now all we have to do is subtract 9 from 15 and rewrite our equation, which would be 1.3 times 10 to the 6th gigahertz. How easy was that? So simple. And we used our chart. So how would you use a metric conversion chart to create a conversion factor? Well, what you're going to do is apply the multipliers to the units with which you seek to form a relationship. So you look at your problem, noting the units that you're given and in what units your answer needs to be given. These two pieces of information will lay the path for how you will maneuver through the chart. Technically, what you're doing with this chart is you're applying the multiplier of the units you seek to the units you want to eliminate, and then applying the multiplier of the units you wish to eliminate to the units you seek. It's a bit of the old green and blue arrow switcheroo. And then after you've done that, you have to be sure to follow the rule for selecting the correct conversion factor, which is that you have to make sure that the units you seek go on top, go in the numerator of your conversion factor. And with that, we are done with our adventure into the world of metric conversion charts. Thanks for watching.